Hello, I'm Kevin Houston, and I'd like to tell you about Chapter 21 of my book, How to Think Like a Mathematician. This chapter is concerned with common mistakes in mathematics. And in this video, we'll be looking at common mistakes arising from the square root function. Okay, let's go. Okay, trick question time. What is the square root of 64? Some people would say plus or minus 8. My aim is to show you that this is incorrect. The correct answer is 8 and only 8. No minus 8s should creep in. If you are caught out by the evaluation of square root of 64, don't worry. It is quite common to be taught that the square root of a number gives two numbers, a positive and a negative one. However, if square root is a function, so we can differentiate, integrate, etc., then by definition of a function, we should only get one value for each input. A good definition for the function is the square root function, square root, from the non-negative real numbers to the non-negative real numbers, is defined by square root of a equals x, where x is the non-negative solution of x squared equals a. So why are we mistakenly taught that taking a square root gives two values? The reason can perhaps be seen in the definition. Square roots and the solutions of quadratics are related. Quadratic equations generally have two solutions, and so we begin to associate square roots with two numbers. For example, to solve x squared minus 4 equals 0, we say, rearrange to get x equals plus minus square root of 4, and hence x equals 2 or x equals minus 2. So we feel that a square root gives rise to two numbers. But note, if it really did give rise to two numbers, then we would just write x equals square root of 4 in the above, rather than plus or minus square root of 4. If you really are convinced that two numbers are produced by a square root, then why do we write the plus minus symbol in the formula for solving quadratic equations? X equals b plus or minus square root of b squared minus 4ac all over 2a. If the square root function gave two values, then it would be sufficient to write x equals b plus square root of b squared minus 4ac all over 2a, as the square root would automatically give two solutions. However, we include the plus minus to get the two solutions, assuming b squared minus 4ac is not equal to 0, as if b squared minus 4ac equals 0, then we only get one solution. Furthermore, if the square root function gave two solutions, then what is the number 3 plus square root of 5? It must be two numbers, as square root of 5 would be two numbers. If I wanted the larger one, I would have to write 3 plus the modulus square root of 5. And if I wanted the smaller, I would have to write 3 minus the modulus of square root of 5. As we never see anyone making this distinction, then I suspect that deep down everyone accepts that the square root of a really is a single number. In summary, remember that square root of a gives one number, whereas for x not equal to 0, there are two solutions to x squared equals a, with a greater than or equal to 0. X equals minus square root of a, and x equals square root of a. I take the a greater than or equal to 0 because I want to avoid talking about complex numbers. Ignoring the difference between square root of a and the solutions to x squared equals a leads to a very common problem. The following equation and its solution should make clear the problem. Let's take the equation square root of x plus 3 equals x plus 1. Then squaring both sides, we get x plus 3 equals x plus 1 all squared. And so x plus 3 equals x squared plus 2x plus 1. Or 0 equals x squared plus x minus 2, which we can factor to get 0 equals x minus 1 times x plus 2. So x equals 1 or x equals minus 2 are our solutions. Or are they? Are x equals 1 and x equals minus 2 solutions to the square root of x plus 3 equals x plus 1? Well, we want to think like mathematicians, and mathematicians check their answers to make sure they make sense, rather than merely recheck their working. You can find more on checking in chapter 5 of the book, and also the video Writing Mathematics 2. Now, substituting x equals 1 into the original equation shows that we have a solution. Square root of x plus 3 equals square root of 1 plus 3 equals square root of 4 equals 2 equals 1 plus 1, which is equal to x plus 1. So that's okay. But if we substitute x equals minus 2 into the equation, we get square root of x plus 3 equals square root of minus 2 plus 3 is equal to the square root of 1, which is equal to 1, but that's not equal to minus 1, which is equal to minus 2 plus 1, which is equal to x plus 1. Thus, x equals minus 2 is not a solution. What's gone wrong? The problem arises because if we have an equation f of x equals g of x, then squaring both sides and solving gives solutions to minus f of x equals g of x as well, since the minus will disappear when we square. We can see this in the following simple example. A equals 3, a squared equals 9, squaring both sides, a equals plus or minus square root of 9, a equals plus or minus 3. So you can see that we've introduced an extra minus sign somewhere along the way. So the point is that a equals 3 implies that a squared equals 9, but a squared equals 9 does not imply that a equals 3. This shows that we should be careful with our use of implications, and that we should include the implication signs to help clarify our working. Let's return to our example. The square root of x plus 3 equals x plus 1 implies that x plus 3 equals x plus 1 squared, by squaring both sides. That's if and only if, in other words, this equation is equivalent to the one above, x plus 3 equals x squared plus 2x plus 1. That's equivalent to 0 equals x squared plus x minus 2, which is equivalent to 0 equals x minus 1 times x plus 2, which is equivalent to x equals 1 or x equals minus 2. Note that the first implication does not reverse, so we don't have x equals 1 or x equals 2 implies that the equation is true. However, we can conclude that the equation is true implies that x equals 1 or x equals minus 2. Of course, when solving equations, we want an if and only if, i.e. a if and only if sign. To achieve this, we need just to put the solutions back into the equations to see which ones work. We did this earlier for the above equation and found that while x equals 1 is a solution, x equals minus 2 is not. Thus, the square root of x plus 3 equals x plus 1 if and only if, or the equation is equivalent to, x equals 1. Okay, some conclusions. The square root is a function, so gives one number. X squared equals a has two solutions, x equals plus or minus square root of a. Actually, that's repeated when a equals 0. Lastly, squaring both sides can lead to too many solutions. Thanks for watching.